Welcome to the electronics class for September the 22nd. I'm recording this ahead of time. I have another commitment on the 22nd, so I won't be able to be there live for the class then. But I'm recording this ahead of time and I'll post this on Canvas and I'll send all of you an email, which I trust that by the time you watch this, you've already received that email. What I'm going to do today is not really talk about the homework that is due on the 22nd. Some of you have submitted that homework ahead of time, and when I look at your submissions, it shows me that you pretty well understand what I had hoped you to get from that homework assignment. So I am going to just introduce one simple new concept today, and then I'm going to tell you what the midterm exam is. Now, you may recall that at the beginning of the year, I told you that many of the midterm exams will consist of simply, I ask you to build a circuit that does a certain job. And if you build the circuit and it does what it's supposed to do, you pass the midterm exam. Now, some of my midterm exams might be more traditional ones where you have to work out answers to problems and submit them like you would in a normal math or science class. But I'm hoping that many of them will be like the one that I'm going to give you today. I just ask you to do a circuit, ask you to build a circuit that does something, and we'll see if you do it. Now, before I do tell you what that project is, though, there is one minor thing that I haven't yet talked about. Some of you already know, but I do want to make sure that all of you know it. Let's talk about a switch. So let me share my my screen here. All right, so what you should be seeing right now is a blank page from Tinkercad where we're going to build whatever we want. And you see this thing right here, the push button switch. We haven't used those yet, but in the midterm exam that I'm going to explain to you in just a few minutes, you're going to be using those switches. So let me just show you really quickly how it works. First thing I'm going to do is call in a breadboard here, and I probably need a battery as well. Okay, and I like to turn my batteries. I don't know why. I just, when it's lying on the side there, it just seems a little awkward to me. You don't have to turn them if you don't want. And also, I want to just get a regular old boring light bulb, not an LED. So did you notice I have to go to all components there? What I want is not in the basic components. So if I scroll down here, so here we are, here's a light bulb, okay? It's not in the basic components in the all. All right, so what I want to do is I want to use this light bulb just because it's quick and easy. This light bulb, you don't need to use a resistor in order to limit the current. If I were to take this light bulb and I hook it up directly to the battery and turn on the simulation, see how it comes on like that? Okay, but I don't want to hook it up to the battery. I want to use a breadboard because I want to make sure that everybody knows how these push button switches work. So there's the push button switch. I'm going to pull it in here. Now these switches are designed so that they go right over the this little groove in the breadboard there, and they plug into those holes right there. Okay, and so inside the switch, it's hooked up in a way that I could more easily show you if I turn on annotation here. Okay, all right. So inside the switch, these two terminals are always connected together. So if you bring in a wire and you connect that wire to here, then the electricity can flow through there and can come out the other side, even if you haven't pushed the switch. And the other side is the same way. These guys are all permanently connected together. So electricity would always flow through there, even if you don't push the button on the switch. But the electricity on the left side cannot get over to the right side if the button's not pushed. However, if the button is pushed, then the electricity can get over there. All right. So what we're going to do is we're going to use this. So because let me clear this here. So what I want is for the electricity to come in. Let me make it a little fatter here so it's a little easier to see. Okay. I want the electricity to come in here, go in through here. And when I push the switch, I want the electricity to flow and come out the other side. Now, if I wanted, I could have it flow either way. Once these guys are connected, it can either flow up and out this way, or it can flow down and out the other way. That's how these button switches and how they work. And also, the button is what we call a momentary switch. Let me switch to a different color here. Right. So momentary. What that means is that the switch is only connected while I push the button down. As soon as I take my finger off the button, then the electricity no longer flows through it. All right, so let's go back and let's see how this works using just a regular light bulb. Now, oops, sorry, I didn't mean to do that. Okay, let me delete that. Okay, so when you guys do this, you're going to be using an LED, and so you're going to have to use a resistor and figure out the proper value for the resistor. But I just want to do it real quick and easy. All right, so what I'm going to do then is let me zoom in just a little bit more. I'm going to connect a wire from there to here, okay? And then from the other side right here, actually I'm going to do it from down here, not just to be different. Okay, I'm going to come there over to here. And then my last wire is going to go from here up to here and then down to my battery. All right. And now one thing that I recommend you do is that any wire that's connected to the plus side of the battery, it's a good idea to make that be red. And so anybody who looks at your circuit, they see that any wire that's red, they know that the voltage on that wire is always equal to whatever the voltage of your battery is, even if the switch is not pushed. Okay. And the same thing with this wire right here, it's connected to the ground. So I'm going to make that be black. And this is good practice for you guys to get in the habit of doing. Then the reason it's black is because that voltage will always be 0, even if the button isn't pushed. Now the green wire here, that's going to be something different, possibly. It's not necessarily going to be 9 volts, not necessarily going to be 0 volts. It could be something different. Its status depends on whether the button is pushed or not. So we don't make that red, we don't make it be black, we just let it be some other color. And you see, we know we have a lot of different colors to choose from. We got, red, orange, yellow, green, turquoise, blue, and blah, blah, blah. So I'm just going to let it be the default there. All right, I think my circuit is all ready to go. Notice because this is a regular light bulb, I don't need a resistor because regular light bulbs have enough resistance built into them. So let's start the simulation going. You'll notice the light bulb does not light up. Now I'm going to hover over the switch here and I'm going to click on the mouse and you see that the light comes on. Now as soon as I let go, the light goes off, right? So light goes on when I push, light comes off when it's not. Now let me stop the simulation here. So this green wire here, I didn't have to connect it down there. I could have connected it up here. That would have worked just as well. Okay, so let's start the simulation going. Notice nothing happens until I push the button. So here I come over, I push the button, light comes on, let the button go, light goes off. And just for grins here, what if I had connected this thing down here? Some people think that with the wire connected down there, they think that I would have to push the button in order for the light bulb to come on. But watch what happens when I start the simulation. See how the light bulb immediately came on, even though I'm not pushing the button, the light bulb immediately came on, right? So that's because these two posts here, they're always connected regardless of whether the light bulb is on or not. So let me just take this back and put it back to a place like, notice I can hook it up to any one of these holes that I want. Oops, that wasn't what I wanted over there. I wanted it over here. Okay, there we go. All right, so I start the simulation, push the button, it works great. Okay, so now hopefully you guys understand how these push buttons work. With that, you are now ready to take the midterm exam for electronics. So what I want you to do is build a circuit that has more than one LED in it. Let me go back here to share my screen again. And let's see, there we go. Okay, here we go. All right, so here is the circuit we just played with. let me show you the circuit that I want you to build. Now, I have hidden some important things here. Let me show you what I've done. Okay, so this thing right here, and this thing right here, and this thing right here, and this thing right here, those are oscilloscopes, and I am not using them as oscilloscopes. I'm using them to hide the circuitry underneath, right? Later, we will learn how to use oscilloscopes. But right now, I just put them there because there is, underneath those oscilloscopes, there is wiring and there are resistors that I don't want you to see, because the test is for you to figure out how the wires should connect and where the resistors should go. So I just want to show you what the circuit does without letting you see how it does it. All right, so I have a 9-volt battery here, and you can see I've got the positive side of the battery that comes over here, and it connects into this bottom row right there. Remember the way that these bottom rows work? Let me just turn on my annotation for a second here. Okay, right. These rows all along here, they are all connected together. So if I were to take the red side of the battery and I were to connect it right to there, any wire, that wasn't what I wanted. Hang on just a sec. Okay, right. Any wire that plugs into any hole along that entire row, it's directly connected to the battery. Okay. And then same thing with the second row. Now the first row is separate from the second row, but everything on that row is connected. All right, so what I've done down here is I've taken the red wire and I've connected it into the very bottom row of my breadboard. And then the row above that, I've connected that to ground on my battery. But you'll notice I didn't go right straight to ground. I went through an ammeter and to ground. Notice I've got this set to read amperage, not voltage. Okay. And I did it this way because I want to measure how much current is flowing when I push the buttons. And a big part of the test is to make sure that the right current is flowing. All right, so anyway, I've got the bottom row of this breadboard is all connected directly to my 9-volt line, but also you'll see I've got a line coming up here as well. So I've got two breadboards, and on both of the breadboards, the very bottommost row is connected directly to the positive side of the 9-volt battery. And the row that's second to the bottom in both cases is connected to the negative terminal of the 9-volt battery, except it goes through an ammeter before it gets to that negative terminal. But as far as we're concerned electrically, the second row is what we call ground in both of my breadboards there. Okay, so now that we know that, let's see what happens here. Well, actually, first, let me just show you a little bit more here. I have 3 LEDs right here. And if I zoom in on them, let me clear off the screen here. And let's come up and zoom in on them. Okay, notice the color. So we've got a red RED, we got a green LED, and we got a blue LED, RGB. And I put them in that order because that's the way people say it. You never heard people say GBR. It's always RBG. And so let's do it in the same way. So I get red, green, and blue. And so when I pull in the resistor, or when I pull in the LED, if you click on it, you'll see it gives you the option to change different colors. All right, so I pulled in 3 LEDs. I made one of them red, one of them green, one of them blue. Okay, let's back up a bit. Okay, all right. So I have hooked up my buttons so that when I start my simulation going, if I push the button on the left, you see how the red button, the red LED lights up? And also, do you notice the current that's flowing is 20 milliamps? All right, so this is what I want you to do. I want you, and so behind my oscilloscopes here, there's a bunch of wiring and a resistor or maybe multiple resistors, right? And they make it so when I push this button, the red LED comes on and I have 20 milliamps. When I push the middle button, the green LED comes on. And again, you can see from the ammeter that 20 milliamps is flowing. And then lastly, the one on the right turns on the blue LED. And again, we have 20 milliamps flowing. Okay. All right, so your job, at least half of your job, is to design me a circuit that does that. But in addition to that, I also want you to make another breadboard, and preferably I want you to have them so they're powered by the same 9-volt battery. And now here, this is a different kind of LED. There's just one LED there, and it's clear right now, but it's got 4 terminals coming out of it. This is an LED that can be different colors depending on which terminal you connect. So if I hover over this terminal, you'll see the software tells me this is the red terminal. So if I want the LED to light up red, I put the proper amount of voltage on the red one. Now the question is, what terminal is the negative terminal? Let's see if it's this one. Nope, or I'm sorry, yes, it is. This is, when it says cathode here, that means this is the terminal that is the negative terminal. So if I want my thing to be red, then I connect up my positive voltage here. This goes to ground, and this LED will light up red. Now, what's this guy? Well, I know that the square that you're looking at is red, and I don't know why the software developers did that. But look down underneath it, you'll see it says blue underneath it. So if I were to make this terminal positive, and again, I always have to have this guy right here connected to ground. So if I make this guy positive, my LED is going to glow blue. If I make this guy positive, he's going to glow green. Okay, so I can get either red or blue or green from this same LED, depending on which lead here I make positive. And the second lead here from the left always has to be the negative one. Okay, all right, so now in my circuit here, underneath those oscilloscopes that I purposely put there because I don't want you to see the answer to how to do this, right? I've got circuits there that will do it. So watch what happens. So I'm going to push, again, I push the red button, or I push the button on the left. You see how my LED there turns up red? And you'll notice I've got 20 milliamps flowing through it. My center button makes it be green, and again with 20 milliamps flowing through it. And then lastly, the one on the right makes the LED light up blue, again with 20 milliamps flowing through it. Okay, so this is a special kind of LED. It's called an RGB LED because it can be any color that you want it to be. And when I say any color, I mean not just red, green, and blue. I can make it be other colors as well. What if I turn on the red one and the green one at the same time? Now, in the software here, it's not obvious how to do this. If you hold down the shift key while you push the button on the left, okay, that keeps the button held down. So I can move my mouse away from here and the button stays pushed down. Right, so now what I'm going to do is I'm going to come over and I'm going to push the middle button at the same time that the left one is being held down. And look what happens. I get yellow. So red plus green together equals yellow. Now, if I want to turn off the red button, I just click it one more time and it goes off. Okay, so what if I were to turn on the green button and the blue button at the same time? Well, let's find out. So I'm going to hold the shift key while I push the green button. You'll notice I get green. Now I come and I push blue at the same time. And you'll see I get a kind of a blue-green, which by the way is called cyan, but you don't need to know that. But anyway, bluish green, okay? And so now what happens if I push red and green at the same time? So I hold the shift key, push red, come over here, push green, and you'll see I get kind of a reddish green color, which is called magenta. That's the name of that color, all right? And so last of all, let's see what happens. Well, I think I've done all of them, haven't I? So, all right, so now what if I did all three of them at the same time? Let's find that out. Say, so here's red, and now I turn on the green at the same time, so you'll see I get yellow. And now I turn on the blue at the same time, and it might look as though the LED has gone out, but in reality, that's white, okay? The LED is putting out white light. So now let's turn them all off again. Okay. So your midterm exam is for you to recreate what I've got right here. Okay. Now, except when you do it, I want you don't hide your answers behind the oscilloscopes here. I want you to show me, because I need to be able to go in and see how have you routed your wires, where have you put your resistors. But mostly, I'm just going to look to see, does it work? You know, when you push the red one, do you get red? And do you get the right amount of current? Now, let me tell you one little thing that you need to know about. The RGB, the LED here, that's the RGB, this guy, let me turn on my annotation here so I can point while I'm talking. Okay. This guy right here, he runs on a different voltage than these guys up here do. So when you guys do the math to find out what resistor you want to use, you know, so you're going to get some number of ohms, and you're going to find out that's the right resistor to put in here for these guys. You're going to find out that that resistor is not going to be the right resistor to use for the RGB down here on the bottom. He requires a slightly different voltage in order for him to work right. So don't just think that whatever resistor you use up here, you can just put the same resistor down here. Not going to work. If you do that, you're going to find out that you get too much current, or maybe too little current, but it won't be the right amount of current. So remember, the things I'm going to be looking for when I grade your final exam is, one is when you push the button on the left, do you get red and only 20 milliamps? I shouldn't say only 21. I want exactly 20 milliamps, okay? I don't want less than 20 milliamps. I don't want more than 20. I want exactly 20 milliamps. With red, same thing with green, same thing with blue. And you see there's a little bit of a lag right there. That's okay if that happens. It takes a little while to respond sometimes, okay? All right, so that's what I need you guys to do. Now, normally I would say, do you have any questions? Because normally you would be live and so I could answer your questions. But unfortunately, like I said, I've got another commitment, so I can't be there on Tuesday. So all I can say then is, if you have any questions about this, email me and I'll be glad to respond to questions. Now, one question that you might have is, when is this due? And the answer is next time we meet. So you guys hopefully are going to be watching this on Tuesday the 22nd, or possibly sooner, but hopefully not any later than Tuesday the 22nd. The next time that we meet after that is going to be Thursday, September 24th. That's when this is going to be due. At the beginning of class on Thursday, September 24th, that's when this is due. If you turn it in late, you will lose points. Okay, so it's got to be due, got to be turned in by then. Now, big question is, how do you turn this in? So here, this is very important. This is going to be a little different than what I've done before. Up until now, all I've said you need to do is just take a screenshot of your exam, take a screenshot of your circuit and upload it. Well, that's not going to be good enough in this case. You're going to have to actually send me a link to your circuit. Let me show you how that works. So let me turn on annotation again real quick. Okay, so if you look up in the corner here where it says share, now on this video here, you might not be able to see the share because the little square that has my head in it, that might be in the way. I wonder if there's a way I can change so that you can see this. Let me experiment here for a second. Okay. All right. I think I've enlarged it enough now that you should be able to see it even with that little window with my head there. Okay. So this button right here, the one that says share, that's the one that I want you guys to use to submit your assignment. So let's see how it works. Okay. So when I click on share, it opens up a window that you can't see because the thing's a little bit too large there. Okay. There we go. All right, so when you click on share, it gives you this little window right here. And you'll see that there's two ways that you can share it, or actually three ways that you can share it, right? Okay, one is that you could share a snapshot of your design. Okay, so if you push this, if you click on that little button, it'll download a snapshot. That is not the way that I want you to do it because I need more than just a snapshot. I need the actual circuit, right? So what we're going to do then instead is I want you to choose this option right here, the one that says share over IM or email. So IM is not the one that I want, okay? Email is the one that I want. All right, so here's what I want you to do. Is once you've got your circuit ready, I want you to click on this button right here that says invite people. So you click on that, and then it will give you a link right here. And if you just click the button that says copy, then that link has now been copied onto the, let's see, okay, there. All right, so when I did this, it went away, okay. But that link has now been copied into your clipboard. So now you can go into your email system and you can write an email to me and email me that link. Now, after you email me the link, don't make any changes to it because that's a live link. And so if you make any changes to your file after you've emailed it to me, then when I eventually get around to opening up the link and looking at it, if you've made changes, then that, I'm going to see the changed link, not the original. Okay, so that is your assignment for tonight. Remember, this is not just a regular assignment. This is a midterm exam. So this is going to count for a lot more points than a regular assignment does. Also remember that in order to get full credit, you need to do both of the circuits. You need to do the upper circuit where when you push the button, you get red, push the other button, then the different LED lights up, the blue one, and then push the third one, and then the third LED lights up. Okay, that is half of the midterm. The other half is the lower half of the circuit. That's where the three buttons all control one LED, where that one LED is what we call an RGB LED. And remember that I need to see an ammeter hooked up to your circuit so that when I push the buttons, I can see how much current is flowing through there. And in each case, if one button is pushed, I only want to have 20 milliamps flowing through it. Now, that brings up an interesting thing here that I didn't mention before. Let's see what happens if we have more than one button pushed at the same time. So let's push the red button here, and you'll see that I get the 20 milliamps eventually. It takes a little while to come up, but it's getting there. Okay. So what if I turn on more than one LED? Okay, so there's the red one, and boy, it's getting slow. My battery is getting weaker. And by the way, this is pretty cool software there. It is, okay, it's not working the way that should. Why is it? Okay, yeah, if you leave the simulation on for too long, then your battery gets weak. So the people who designed this software, they really thought of everything. That's pretty cool. Okay, so let's go back and let's restart our simulation. Okay, so now I push the red one and you see it goes right to 20 milliamps, right? So when I restart the simulation, I start with a new battery. Okay, so let's turn on red and also green at the same time. And you'll see that the current is going up and there's the blue at the same time, okay? The current is now going up, but it didn't go up as much as you would think that it went up. And there's a reason for that, which I don't want to go into now. If you guys want to play around with that, you're certainly, you have my blessing to play around with it. But yeah, if you turn on multiple LEDs at the same time, it gets a little complicated because now we're starting to have what are called parallel circuits, which is the next thing we're going to be talking about. What we've done up until now are called series circuits. After we take the midterm exam, we're going to get into different ways to hook things up that's called hooking them up in parallel. But let's not worry about that for right now. For right now, let's just assume that we're only going to push one button at a time. And so the current will get up there to 20 milliamps. You know, notice it took it a little while to get up there, but that's okay. All right, so I don't want to muddy the waters anymore. Let's just go ahead and end right there. Normally I would say, do you have any more questions? But since we're not live, well, that's not gonna work. Okay, so like I said, if we have any questions, please email me. And with that, I will say goodbye and I'll see you guys on Thursday.